In this video, we'll discuss some basic properties of logarithms. This will be part one of a series, as there are some more complex properties of logarithms that we'll talk about in a later video. So let's start by just looking at some properties of logarithms. So in each of these, we'll essentially have the logarithm rule written, the property written, and we'll kind of talk about where it comes from. So like for instance, log base b of 1 always equals 0, and this stems from an exponential law. If I was to convert this into an exponential expression, or I guess an equation, it would be b to the power of 0 equals 1. And this is an exponent law that is very familiar. Anything to the power of 0 is 1. Basically, I'm just converting it into a logarithm, which we've talked about how to convert in a previous video. So this is a direct extension of this rule that we understand about exponential expressions. So if I'm having log with any base of 1, it'll always be 0. On a similar note, if we take a look at another one here, log base b of b equals 1. Again, if we convert this into an exponential, it would be b to the first power is equal to b, which again, if we just convert it back, here's where we land. So if I have log base 10 of 10, that's 1. 10 to what power is 10 is basically what I'm asking there. Well, it's the first power. So again, kind of on an introductory level here, basic property, we're looking at a direct extension of an exponent law that we all know. Now here are two that are a little more complex. Both of these, I like to think of them as compositions. So this is essentially you're composing a logarithm with its inverse. So if f of x is equal to b to the power of x, f inverse of x is equal to log base b of x. Now if we think about it, if we compose these two functions, so if we had f inverse of f of x, well, that's right there. And we know that when we compose a function with its inverse, it brings us back to x. And likewise, if I compose a function and then on the inside of that is the inverse, well, we have this. We're essentially taking our logarithm and putting it in the exponent here. And likewise with the one above it, we're taking our exponential expression and we're plugging it into a logarithm. Now, if these bases are the same, which I guess I should denote them as capital letters because they are the same, then essentially the log will cancel out the base of the exponent, and the base of the exponent will cancel out the log on the bottom one. So these ones don't come up very often, but they are useful if you're trying to solve logarithmic or exponential equations. And we'll get to that in some time.